RockTrue Science is a cross-cultural response to the lack of diversity in STEM fields. STEM stands for science, technology, engineering, and mathematics. RockTrue Science is designed to serve the intellectual need of fallen man while serving the desire for interdependence to better understand our physical world while still pursuing spiritual growth. Rock True Science seeks to inspire, enlighten, and highlight upcoming and established local and international kings and queens of STEM fields while promoting Black consciousness and awareness of who we are and to whom we belong. Welcome, welcome, welcome to another Rock True Science show. So I'm excited because so the thing with the name, the group three the icosagens. So it has several names. So this is not the IUPAC name. The IUPAC is like the governing scientific naming body. So like all the science names, the people who agree on what you call stuff in science, that's what IUPAC is. So it's like the super technical, like I guess like higher level, like scientific, whatever. But most like secondary school, like middle school, high school, they refer to these as group 3 elements because the transition metals, which is really the real group 3, is this long, the long middle portion. So it's like, okay, y'all got a lot going on, so we just going to jump here because of, as I was talking about in earlier episodes, the valence electrons for this group is 3. So it's easier to teach it that way, especially when you're learning the foundations of the periodic table and the elements and things. So it just keeps it simple. But technically, this is group 13. All right. But so if you're searching for like other stuff about it on the internet, search group 13, you'll find more pointed information that'll actually get you the correct grouping. So the only reason why I found this particular thing is because the people who make these infographics, they understand basically how it's taught, and they're trying to reach, like how we are, many levels of understanding of the material. So our group 3/13 elements are comprised of metals, and then boron, being the little oddball in the group, is the only non-metal that's grouped in, but it's considered a metalloid, meaning it's metal-like. So because of its electron configuration, it forms a lot of the same bonds that the metals in this group does, but its other chemical properties are completely different. Like its melting point is super duper super high, and the rest of them, because they are very metallic in nature, their melting points are much lower. Like for instance, gallium actually melts in the from the heat of your hand, and it's not toxic like to your skin or anything. It might oxidize it a little bit, so you'll have like a little bit of a stain on there, but it's not like, oh my gosh, I'm gonna have like skin poisoning or anything like that. But and aluminum, our is very common. You've heard it a lot, aluminum foil and things like that. As you can see there, it is the third most abundant element in the Earth's crust. So we understand that the core of the Earth is mostly iron, and then the crust, which is like the ground, the soil, the stuff that we stand on, is comprised of several different types of minerals, and aluminum is the third most abundant. So aluminum is also the active ingredient in most commercial deodorants. So I understand that a lot more people are getting more health conscious. They're asking more questions about what's in the stuff that they use all the time, especially if it's used directly on your body or put into your body. So when I got pregnant, I actually like really paid attention to that, and aluminum is considered a heavy metal. So it can present toxicity issues like at higher levels, just like any metal would in your body. But it is fairly safe for use, which is why it is in deodorant, but it can cause problems. So especially, me being pregnant, I'm like, want that crap going into my baby. So I tried to find natural deodorants. A lot of them are like shea butter, cocoa butter based, and they'll put like different essential oils to kind of like hide your body odor. But the issue with that is that cocoa and shea butter is delicious to the bacteria in your armpits. So it doesn't actually keep you from smelling, at least not too long. And depending on the voracity of the bacteria that live in your armpit, those smells can kind of become overwhelming. So I've still been on the search for a new organic non-metal containing deodorant. I've been seeing, the ads for that Lumi deodorant like everywhere. I'm gonna try it. I'm gonna check it out. So I've been, they've been getting more into the science of it. I'm like, oh, okay, I like what's wrong with the stank. I mean, it ain't nothing wrong with the stank if you by yourself. But when you get around other people, it might be a slight problem, depending on the situation and all of that. So that being said, we can, find alternatives. And like I said, I'm still on that search. So if you find something, let me know. But I know, right? Let me, you got me, I got you. All right. Boom. So that's one of the interesting things about that. And the reason why they use aluminum is, one, because it's generally safe for use. Like I said, it's not like highly toxic, but it can have some, some biological kind of interactions and things, especially over time. And it hasn't been linked to like juices and berries, but juices and berries feed bacteria like a lot. Sugar is like bacteria's favorite thing. So the reason why you smell is because, and I learned some of this extra stuff, and I like the animations from the ad. Like, I'm telling you, I'm finna try them out because I like how they get the information, and they're actually trying to educate you as well. But bacteria eats your body liquids, so your sweat and all that stuff. And your sweat contains stuff like minerals, magnesium, sodium, the electrolytes that you replace when you drink, Gatorade and things like that. Your sweat contains that stuff, and the bacteria eats it. And the smell is not actually you, it's the byproducts from the bacteria. They release gases and things like that. That's why your farts stink, because the bacteria in your intestine is eating something, and they're probably dying. If it smells really bad, that means you're probably ruining your microbiome. Like, all your little bacteria friends are dying, and you should hold a funeral and eat you some probiotics and some vegetables and fiber. But the whole thing with the way aluminum works is, and pretty much all the group 3 elements, is they have these 3 valence electrons. So like I said before, all of the elements in the periodic table that are not noble gases are trying to be like noble gases. So they are either very ready to give up electrons to become like the noble gases, or they're very ready to receive or take electrons to become like the noble gases. And so the group 3 elements have 3 valence electrons that they are very willing to give up to have a nice full 8 electron outer shell. And aluminum is one of them. And so in doing this, it binds, it creates what's called a chelate. You can bring up the picture of I think I have it labeled chelates. And it shows how, because they all pretty much operate the same way, because like I said, they have these 3 attachments. So for the most part, when you see elements and like chemical structures, you'll see like these lines. The line represents a bond, and then when it forms a bond, it's actually electrons that are sharing their energy between those 2 elements, creating the molecule. And so for the most part, a lot of elements are forming 4 bonds. There are some, and depending on their size as well, they can actually form more bonds or fewer bonds. But the group 3 elements, no matter their size, really only like to form 3 bonds, which is strange, especially when you're getting more into the inorganic chemistry of stuff, which is also a whole field in itself. So if you're interested in this type of science, inorganic chemistry deals with inorganic elements and molecules. Well, molecules. So basically, an inorganic molecule does not contain carbon. So it is not forming bonds with any carbon containing molecule, and it does not include carbon. So that's what inorganic chemistry is, and it mostly deals with obviously metal, because metal doesn't have carbon in it. And so a lot of the advances, especially like with deodorant, was probably the work of an inorganic chemist and a couple of other different kinds of scientists like biologists and, you know, biochemists and things like that, to understand the reaction between aluminum and your body bacteria and things like that. And that's how they do. So a lot of the scientific and technological advances and even mathematical advances that we have are usually a group effort of people from all of the fields of STEM. So your people in technology will write or create algorithms and programs to help with the visualization of these compounds or these reactions, or they'll create programs that you know, work the machinery that your mechanical engineers, so your engineers are coming in here building things to help analyze these, you know, these experiments or collect data. And you have the scientists that create the experience, like, so everybody works together. So it's not like you pick one field and it's like you kind of the odd man out. Like, no, everybody is going to have their hand in the pot at some point in time, because that's just how science and everything works. Everything is very interconnected. And I think that's probably why I settled on chemistry, because chemistry really did touch on literally everything. And I don't know of any chemistry program at any school that doesn't require you at some point to take at least one class from that includes something from the other fields. Like everything, like you gotta take calculus. That's a lot of math, and it'll make your head hurt. But you do have to be I would say exposed to a lot of things. So physics, biology. I had personal interest in like genetics and things like that. So I took genetics. Biochemistry is actually my concentration. So I took a lot of biochemistry classes, but also, you know, you got physical chemistry. So it's like the physics of chemistry, which is another class that made my head hurt a lot. But there's a lot of interconnectedness, and especially if you go to a liberal arts school, you're going to have something from all of those fields. So you might end up going in thinking you want to do electrical engineering or, you know, coding or something like that, and then you take a class and you realize that you're really more of a hands-on person and you want to do more things that are more practical as opposed to theory or, you know, whatever. So definitely try stuff out. Yeah, try stuff, because you never know what you might find out that you like, or that you're probably more you're better at or have more of a passion for. And this stuff will it will weed you out very quickly. We call organic chemistry, which is usually like the second class. So you have like general chemistry and you have the second class of general chemistry, and people usually take that one with organic chemistry. So you usually have 2 semesters of organic chemistry as well. So by the time you get, oh, hold on, my mom's back. So the organic chemistry class tended to be the weed out class, because it had a lot of fine detail about how these elements work and fit together. So instead of just looking at the bonds and the stoichiometry is basically chemistry math. So instead of just looking at the kind of surface level stuff, now you're going into this type of stuff, the valence electrons, how they move, and so with that there's also the electron shell configurations, which is the orbitals. So the rings that you see here on the aluminum, those are called orbitals. So the innermost orbital is the s orbital. The second one is the p orbital, and then the next one is the d orbital. And then the larger ones, I'm like gallium, indium, thallium, and enuntrium. Those would have f orbitals, which not a lot of elements have. The really large ones do, and they actually, the energetics of them are actually more intertwined. So then you have these levels. So you have 1s, and the s orbital can hold 2 electrons, and then you have 2p. So it doesn't go 1s, 2s, and then you just count up s's. So they actually intertwine. So it'll be 1s, 2, and then 2s, 2, and then you go to 2p, and the p orbital can hold 6 electrons. And in aluminum, what happens is the 3 electrons in the d orbital get lost. So then it has its happy 8 electrons, and it has this, and actually when you start writing out the orbital, well, the electron shell configurations, an abbreviated version is you just write the element, the elemental symbol for the noble gas configuration that's closest to that element, and then you add on the additional orbitals and electrons that make it that element, instead of like I think for aluminum it would be helium or neon. No, I think, yeah, because neon is on the same line as boron. So it would be neon, and then you would write the rest of the orbitals and the other electrons that would add on to however many neon has. I think neon has like 15, not 15, 16. I want to say 16, something like that. So that's how the electron shell configurations work. And so there are it gets real spicy. So that's why, and that's just that portion of it. So that's why organic chemistry tends to be the weed out class, because there's a lot that goes into it. And then the more you do it, the more you memorize. And if you don't memorize enough stuff, it can be extremely difficult. So at one point in time, I used to have all of the electron shell configurations memorized up to like the 5D or 5F something, and even like how they're interspersed and all of that stuff, the noble gas configuration that fits, and like a lot of this stuff, it comes easier the more you practice it, which is why they give a ton of homework, and it's in your best interest to do it. And I wasn't always on top of that, but kids, do your homework. That's why. Because the practice helps you actually not just learn the material, it helps you memorize the necessary tools to make learning easier. Ta-da! So that's my little plug for homework and doing your homework. All right, adults, do your homework too, because some of us are still in school. Do your homework. So some interesting facts. So it was some stuff, because I had wanted to like try and relate this stuff back to stuff that that we as normal citizens, civilians would care about. Like if you're not actually in the STEM field or going to school for it, like you'd be like, oh, okay, this sounds complicated. Next. So here's the uncomplicated stuff. So boron is actually found naturally in food. So we actually do end up eating boron, and it's not extremely abundant. And there's actually no research that indicates that there's a toxicity level for it. But it's like one of those things, like just because we don't know it's toxic, like that doesn't mean it's not toxic. So don't overdo it. But studies have found, and this is what I found this on healthline.com. I love healthline.com, like for all the body stuff, because like they really do their research, and they cite the sources directly. Like you can click on the link in the article and go to the actual physical research article, and it's not just like a summary, and they took out stuff that supports what they're trying to push. So they're not trying to push any angle. They keep it very objective, and that's why I love them. So this was found. Did they write the journal? No, I didn't write the journal down. It was for the next one, for the brain. But this one is if you take in general, we get 1.5 to 3 milligrams of boron in our regular diet, just from eating food. And that's if you eat like healthy food. So this is not pertaining to like fast food, processed foods. I don't think anybody is doing research on how much, like, what nutrition is like. They just say, just don't eat it. Just leave it alone. All right. So if you eat fresh fruits and vegetables, all right, then you're probably getting about 1.5 to 3 milligrams of boron daily. And there's no minimum recommendation. However, there has been a study done where if you take like a supplement of about 3.25 milligrams. This is what the study specifically says. I guess that's the amount that they used in their experiment, because remember, we talked about that the first show. Experimental method. So they added 3.25 milligrams of boron to their diets, and they had a better memory and hand-eye coordination than people who didn't, or who exhibited a deficiency. So they don't, and the crazy thing, they don't know how that worked. Like, they don't know how that helped improve any of that. They just know that when people increase their boron, that happened. So there's a lot of stuff like that that's kind of like not fully researched. So that is why there is still a very wide open field in all of the STEM fields, because there's always more stuff to figure out. Like, well, why does this work? Well, why does that do? Like, constantly asking the question why, and constantly searching for the answer. So don't ever count yourself out. You might be that next person that discovers the next why. Okay. And then boron for your bones and joints. Like, this is one that really like took me back. I didn't know that there's a link between the amount of boron in your body and the amount of vitamin D in your body. So if you have a vitamin D deficiency, you could very well have a boron deficiency as well, because boron has been found to extend the half-life of vitamin D. So the half-life, I think I mentioned this in an earlier show too, when referring to radioactive material. So if you've been around long enough, you've probably heard of a half-life, and it's usually in reference to radioactive materials. But every single element has a half-life. Okay, we just usually don't care about those half-lives because they're not giving off, free radicals and stuff that causes cancer and all that. So we're not paying attention to that stuff like vitamin D. So the half-life is the amount of time it takes for the concentration of that thing to be half of what it started out as. And so with boron, it actually makes vitamin D last longer in your body to do its job longer. So that is very interesting. And it also has the same effect with estrogen. And estrogen in everybody, so everybody thinks estrogen is like the female sex hormone or whatever, but no, estrogen is in everybody, and it is necessary in everybody. Why? Because estrogen is directly linked to calcium in your bones. So your estrogen levels will actually determine how much calcium remains in your bones. So if you have low estrogen levels, like below normal for your body, whether you're a man or a woman, if your estrogen levels are low, you could very well end up with low calcium in your bones, and that leads to osteoporosis, brittle bone syndrome. Like, if you have easy breaks and things like that, that might be something to look at. Your estrogen, vitamin D, and calcium. Vitamin D is necessary to absorb calcium into your bones, which is why you want it to be able to do its job for longer. And is that it for that one? Yeah. So I thought that was interesting about boron, because I only thought of boron as like the funny little non-metal that's kind of like a metal that makes 3 bonds. Like, That's all I ever cared about it, because I'm a chemist, so that's all I learned about it in chemistry. And we didn't have to study it, like, specifically in here, give my daughter her phone so she's not messing with mine. So we didn't actually look at its efficacy in the body or in biological systems. Now, mind you, a lot of this research also is done mostly on rats. So you can imagine the applications and shortfalls of the outcomes for a lot of this stuff. So a lot of the studies that I tend to look at, like, they're usually studies. So they either directly give people the stuff, or they end up like in a supplemental form, or they just kind of track what they eat, and then like, kind of have to do more observational type studies with when they go to like human stuff, because the ethics and the morals and stuff, like, you can't just experiment on humans without like going to jail. So so, and a lot of times, like, even if they agree to certain stuff, like, there's still like moral and ethical dilemmas, because sometimes people don't know what they're agreeing to. So there's very few human studies that tend to be done on like a lot of things that we are more concerned with, which is like the nutritional value or the toxicity of certain things. So that's why it's like a big gaping hole in that body of knowledge, and like a lot of stuff is kind of educated guesses. And that's what an educated guess is from the research done on rats, which are not human. Gallium. So gallium, indium, and thallium are the next few actual useful elements. Anuncium is probably like very, very like rare, and probably wouldn't be used in like research or nothing too much, or especially not in like wide or public use. So that's why people rarely talk about the elements that are like 100 something or bigger, because they're really rare or extremely toxic or very radioactive and unstable to study. So we don't. But hey, Marley King. I know, right? That's a whole can of worms right there. Right. So gallium, indium, and thallium are elements that are used widely in electronics and technology. So microchips, TVs, indium is one of the main substances in touchscreens. So indium, haha, is the reason why when you touch your phone screen, it responds to you. So it's very it conducts electricity very well, and our bodies have electricity in them. So that's why it can read your fingers when you move it across the screen. It in the screen, it's a compound it makes called indium tin oxide, and or ITO. That's what they use in your touch screens, flat screen TVs, solar panels, and it bonds strongly to glass, so that's useful. Okay. And that's why solar panels are glass. And it's transparent, which is also useful, which is why you can see stuff on your phone and it's not like blacked out or have an odd color and things like that. So, and I also, and also when it's, they call it dosing, but basically if you have with germanium, and dosing just means like you introduce it as is in its elemental form to germanium, and it reacts in that way to create transistors and microchips. So it might be like a type of plating process. And it's also used, this is indium, yes, it's also used to find certain tumors in the body. So they'll end up like putting it in you through an IV, and as it travels through your body, it'll bind to the tumor. That's why it's specific tumors, because I'm assuming it has something to do with the chemical properties of that tumor or the place that the tumor is located. And so that's why they can use that to, I gotta turn my daughter's phone down. She left it sitting next to me with the volume turned all the way up. So it'll bind to and allow them to see the tumor. When they like do some type of imaging and stuff, because it's still a metal, so it's going to show up on their imaging equipment, which I'm pretty sure that might not put you in an MRI with that, but it's something else. And gallium is also used in electronic circuits, semiconductors, LEDs. So that's your light emitting diode. So not the really nice TVs, but they're good enough. They're usually flat screens still. Like monitors tend to be like LEDs and things like that. But gallium is not found in its elemental form. Like, if you go in an aluminum mine, I guess, they would find little nuggets of aluminum, but gallium is not found like that. Gallium is actually extracted from an ore called bauxite and sometimes sphalerite. And so ores with those weird names, they tend to be collections of a bunch of different minerals, and they have to put it through a process to purify it and separate the metals, and that's how they get gallium. They can only get it by purifying the ore that they find and separating it from it. And that was the one I mentioned earlier that will actually melt in your hand. Thallium, this was interesting as well. So thallium is used in the manufacture of electronics, low temperature thermometers, optical lenses, and cameras. So thallium. Thallium, like, that's so cool. And you think like, oh my gosh, how did they figure that out? That's why people are needed in STEM fields. How did they get their most of the elements got their names from the people who discovered them. And yeah, especially like the higher numbered ones, they're usually named after the person who discovered them. A lot of the core ones and the non-elementals like oxygen and stuff like that, they have more of a Greek or Latin origin, and it usually pertains to how they found it. And imitation precious jewels. I thought that was strange. Like, they put thallium in imitation precious jewels, and it's just like, I wonder how that works. Or in general, what are they derived from? Yeah, like with iron. Iron's actual name is ferrous or ferric, something like that, and that literally it literally means iron in Latin. So some of them have Latin like origin names, and then we just kind of just use the English version of it to say that, or the non like origin word, because it's usually a mouthful, and people like to keep it simple. And silver, the symbol for silver is Ag, but it's definitely not silver. And I forgot what that was. It's like agnium or something like that, something weird. But yeah. Is it true that China is the one mostly extracting those minerals? It depends, because like a lot of the minerals that are used are actually extracted in like a lot of those different regions. So like, yeah, China, but not so much in China. They're probably more so the manufacturers like put together the stuff there, or it's closer to China. But there's a lot in the Middle East and Africa as well. So like just pretty much that whole region has a lot of different ores, and even still the mining methods are, affecting the entire planet. So yeah, just because it's happening on the other side of the planet doesn't mean it's not still affecting us. Be careful, Duda. I don't know. She flipped, and yeah. And was that it for thallium? Yeah. Oh, and fiber optics. So the melting. Yeah, you can see the melting point. So the melting point for all of these group are on that little thermometer line in order from lowest to highest. As you can see, boron is the highest, because like I said, it's not actually a metal. It's a metalloid, because it has properties like a metal, but it's really a non-metal. And so it has a pretty high melting point. and gallium actually has the lowest melting point, which I said you can melt it in the palm of your hand. And thallium is kind of like mid grade between indium and aluminum. So and that's also why foil doesn't melt in the oven, because as you can see, it has a really, really, really high melting point. So that's why we use aluminum for everything, and it doesn't really hold heat that easily either, which is why if you put an aluminum pan in the oven, and you can almost like take it out with your bare hands without burning yourself like immediately. Like, depending on how hot the oven is, like, don't do that. Use oven mitts. Safety first, okay? Use oven mitts and all of that stuff. But it's not going to be as severe of a burn as like if you use iron, because iron absorbs and holds heat for a long time, and it holds a lot of heat. So yeah. Oh yeah, we did that in the experiment. So yeah, that's why the little iron puff basically burned up, but it didn't actually release flames, because it drew the oxygen to it and it absorbed the heat. But because the little iron rods were so thin, they were able to burn, as opposed to just transferring the heat to the rest of the iron portion, like in an iron skillet or iron machinery. So that's why we have engineers, because they're the ones that figure out all of this stuff. Like, okay, well, what is it being used for? What conditions is it going to be used under? And then that's when they come up with these alloys and things like that. And boom, speaking of alloys, I got a quick video for y'all. That's going to be kind of fun. So yeah, you can pull the video up. So this is a video of a, what do you call it? A regenerating battery. So basically, no matter how much they cut this metal between the two ends, between the battery and this clock, they can't stop the timer, because the current just finds a new way to travel through this. I believe it's gallium and indium alloy. I know for sure it's gallium, and they mixed it with another metal, and it created this phenomenon where you can't actually cut the wire. As long as there's something that connects the battery to this clock, is going to keep running. So yeah, put the video. Did you get the video? Will, where'd you go? Okay, I don't know. He might not be here, but I do got more to talk about though. So all of this being said, we can think of like, oh, no worries. So yeah, he's remote. So no video this time, but it's cool. But yeah, so basically they have this alloy where no matter what part of the oh no, whatever part of this, alloy that they cut, they can't stop the current from the battery to the clock. So they did, and the kind of messed up part about science and discovery and things like that is that it can be misused for harm and evil intentions and things like that. So they did bring up where it could make them the bad guy for coming up with something like this, where if they were trying to defuse a bomb, it didn't matter what wire you cut, because you would never be able to stop the timer, because it's still connected. And then if you cut all of the wires, you could potentially still set the bomb off. So there's that. But then there's also very, very good and benevolent connections that can be made, where like there are certain machine. Hold on, let me get her. She didn't want. She shut out. So there are certain applications where there might be something that's either very hard to repair, or that you just simply can't repair once you put it together without disassembling the whole thing, or whatever. Or different applications like that where something like that will come in handy. Like no matter how damaged the thing is, it will still work. So, the double-edged sword thing, like the whole giant atom bomb that, destroyed almost a whole civilization, that wasn't even the intention of or the use of Einstein's theory. Einstein actually intended his theory to be used to make renewable energy, like so that we wouldn't have to keep burning coal and ruining our environment and all the stuff that we're experiencing now. That was his intention, to kind of avert that. But then once that theory was misused in that way, all of the stuff that would have been used for renewable or sustainable energy got taken away, put under lockdown, because now it's a weapon as opposed to being an energy source. So that kind of sucks, because sometimes people suck. And with that being said, you can become I thought of some of the careers and things that would deal with a lot of this kind of stuff, and electrical and mechanical engineering, or a materials scientist, and also, like I said, just an inorganic chemist. So you can also, most of the research is done by PhD. So unless you want to be in school for 10 plus years, you can just be on a team with a PhD. You don't have to, be a PhD to do the research. But to head a research team, they do usually require a PhD, because they're not going to give their money to a master's student or an undergrad student without someone overseeing that project to make sure stuff isn't going to waste. So that's something to keep in mind. So especially if you're starting early in your education, you're in high school or something like that, it's better to plan out how long you you intend on being in school, and then kind of go from there, because kind of winging it, especially with the STEM fields, is difficult, and it can make it even more difficult and expensive. So planning ahead for those type of fields are extremely useful. And then there's, like I said, there's a ton of scholarships for STEM fields, especially if you are considered a minority, which means if you're not a white man, like literally, like a white woman, even, like you're still considered a minority in those fields, because there are very few women of any race in the STEM fields in general. And like basically anything. So if you're not a white man, they have a scholarship for you. So get good grades, do your homework, study, and someone will throw money at you for going into a STEM field, and you will absolutely have a job when you graduate, because you will help them fulfill their affirmative action or diversity requirement in a predominantly white male dominated fields. Like all of them are pretty much white male dominated. So if you are not a white man, you will absolutely get money to study this stuff. So yeah, don't ever count yourself out. All right. So sometimes not being the most common factor is really beneficial and advantageous. So definitely use your uniqueness to your advantage in all walks of life. Okay. And what was I looking at? Oh yeah. So boom. All right. So like as I was saying about the aluminum in your deodorant. So back to when I was pregnant, I was like, okay, so I'm gonna just stop using deodorant. I wasn't that smelly when I was pregnant, but after I had my daughter, it was like my hormones and everything like kicked back in. I was like super like odorous. Like I could smell. I could still smell myself even in the shower scrubbing my arms. That's how bad it was. But I refused to put more of that deodorant on me, especially while I was breastfeeding and everything with my daughter. So I just kind of had to, thug it out. She didn't want to come in. But I had to it's over here. So I had to thug it out with that. But there are certain things that you can do to detox your body. Now, I know like that word gets thrown around get thrown around a lot, and they have all these detox teas and mixtures and all that stuff. But for the most part, your best detox system is your kidneys and your liver. So eat things that are going to protect and improve the function and health of your kidneys and your liver. That's like, that's it. Like, that's it. I'm not even going, like, I don't even have nothing to promote to be like, yeah, here, drink this. Like, no. So most of the time, like, you just kind of hear detox in general and you don't know what is actually detoxing from your body. So you have to, like, kind of ask the question, like, well, what does it detox? And if they can't really answer that, I would just kind of, not buy it or waste your money on it, because if they don't know what it's actually detoxing, then it might not even be useful. So for the most part, antioxidants are really good. So your green tea, and for the same reason that aluminum is useful in deodorant, is exactly the same reason why green tea is so bomb at detoxing heavy metals from your body, because it's a chelating agent. So a chelate is basically a compound that makes a whole bunch of bonds to a substance, and it basically locks up its active sites. So aluminum, basically all the group 3 elements they form chelates very easily because of the 3 bonds that they form. So it tends to, make this bond, this triangular bond, like with it in the center, and it'll bond to other stuff, and then it basically locks up the active sites of these things. So there are antioxidants and things in stuff like green tea, spirulina, chlorella. I believe those are algae or something from the sea. But you can usually buy them as like a powder supplement, and you can add it to like whatever. For the most part, as far as I know, it's tasteless, or like the taste is manageable. So if like you mix it in with juice or tea or something, you won't really taste it. Um, Barley grass juice powder, cilantro. Go figure. Garlic. Okay, garlic. Tried 2 different natural deodorants, and after a couple of days, I was like, "Nah, man, this ain't it. I'm gonna pray for protection." I went back to Secret. Yeah, but no, that's the thing. Like with the when you transition to natural deodorant, you do have to give your body time to detox itself from the aluminum in the commercial brand deodorant. So it's not gonna work like that great for the first couple of weeks. Like for me, like even now, like I still, like, I have like a spray deodorant that I use. It's not an aerosol. Okay, it's a pressure deodorant. Once it gets empty, it stops spraying stuff. But that's about, and I just use that because I sweat a lot. I sweat a lot. And then, like, in doing kung fu, like, I don't want to be funky while I'm sweating in this room with all these people that I'm training with. So that's why I kind of went back to that. But that's why I want to try that Lumi deodorant, because if it works, like, I can completely, cut off the aluminum based deodorant. So I'm definitely, I'm gonna check it out, and I'll let y'all know. Spirulina worked magic for me and body odor. Haven't worn deodorant in years, even being an active guy. See, detoxing. That's what detoxing does for your body. So in detoxing also, like, and that could very well be like when you detox your body, you change your microbiome. So the things that grow and live on you are going to be different than if you're full of toxins. So whatever you eat, the bacteria eat too. So if you are eating stuff that is toxic to you, it's also toxic to the bacteria that live on your body, and they die. And when they die, other bacteria eat them, and then they make gases and all kinds of other stuff that stink, and boom, you got smells. So that's why detoxing with natural foods, like, eating properly, getting your antioxidants and stuff like that. Oh, wild blueberry, lemon water. It's super simple. Like, and that's even like a recommendation. When you first get up in the morning, have you a cup of lemon water. Not only obviously is it detoxing, but it's also it helps promote good digestion. So if the first thing in the morning that you drink is some lemon water, you're going to jumpstart your system. You're going to hydrate yourself properly, and boom, you're also detoxing. So you don't have anything that your body is digesting because you've been asleep for 8 hours. So that's why they call the first thing you eat breakfast, because you're literally breaking a fast. So it's better to drink that stuff while you're fasting, because your body is not focused on digesting stuff or, putting, metabolizing all of this stuff. So your metabolism is basically done. It's cut off, it's shut down, and you can jumpstart it with water. And then instead of it trying to break stuff down, it's like, oh, now it's like rinsing your insides. That's how I think of. That's why, like, the first thing I do, I drink a fat cup, like probably like 24 ounces of water. I put my straw in it, and I go about my morning routine sipping my water. And I usually have like some mint or lemon in it. And mint is also really good for your digestive system too. And it tastes good, and it makes your breath smell good, and it also helps kill the little bacteria that live in your teeth and your mouth and your tongue and stuff that make your breath stink. So that's why your breath stinks. And also, like, your breath is a really good indication of your health as well, because your stomach, so like if you have real bad indigestion, you might end up having, like, you might have bad breath as well, and you think it's just like, oh, I just need to brush my teeth, or you chew some gum, but really it could be an indication of poor digestion, and you actually have like food that's like souring in your stomach, and you can smell that. And also, like, certain diseases release smells and things into your gut that comes out of your mouth. So depending on, I guess, like what you have, your doctor might like ask, like, do you have bad breath? Like that, they'll ask that because that's actually a symptom of that particular disease. Is sea moss as beneficial as they say? Yes, it is, and it's mostly because it has all of the nutrients and minerals that well, not all of, but like I think it's like 92. So it has a large number of stuff that your body needs, and if you don't eat a well balanced, well rounded, diverse diet, then cucumber lemon water is delicious. Cucumber is great for hydration and lubricating your digestive system, and it just tastes refreshing. Like, can't beat it with a stick. But yeah, so that's why sea moss is really good, because it just has a lot of nutrients and stuff that a lot of people, especially if you're on the SAD diet, the standard American diet, like eating a lot of fast food, processed foods, fatty foods, sugary breads, white bread, like extra processed bread, then your microbiome is trash, and your digestion is probably even worse, and your metabolism is like shot, because you basically kill all of the bacteria that live in your gut and your intestine that help you digest your food. And not just digest it, they actually help with the absorption of certain nutrients and minerals, like certain things that you absolutely can't absorb without certain types of bacteria, and they die very easily when you eat sugar, especially processed sugar, and processed, like, what are they called, refined carbs. So that's why the whole big movement back to natural is that, because you're literally killing yourself from the inside out when you eat that garbage. So yeah, let's stop doing that. Okay, get you some fiber is a great prebiotic. And then also, another way to detox your body is get probiotics. Like, the bacteria that live in your body are like super efficient with everything that they do, because they're this big. So when you're this big, everything has to make sense for you. Like, literally everything. Everything that you eat has to have some type of purpose for you, because you are one cell big. So one thing goes wrong, you will die. So they're picky about what they eat. They're very I would say meticulous about their environment. So they secrete their own antibiotics. That's where, like, the whole idea of antibiotics came from. The guy who came up with penicillin, I forget his name, but I know penicillin is tight. Okay. But that's also why you have superbugs, because it's been overused. And penicillin is actually a very strong antibiotic. It kills like almost everything. So the way antibiotics came into being, like outside of penicillin, they existed long before we did. So because that single cell didn't want nothing around it, because now you have to compete for stuff. So what the bacteria do is they knock out their competition by creating antibiotics. So you get these similar bacteria that live together, and they secrete stuff that are byproducts of whatever they eat out of their environment, and they contain antibiotics that kill other bacteria and basically mark off the area. So bacteria are very territorial. So that is why your microbiome is very fragile. Where can we find purchase sea moss? Oh, I was getting mine from Karen Date. Yeah. I believe it's called, I believe it's karendate.com. I think, Will, what was your uncle's website? Like, some of everybody sells sea moss now. Like, seriously. Like, ask your neighbor. They probably sell it. Like, quite seriously. It's, I mean, people are like been creating businesses out of thin air, and it's like, if you got the will to, get behind it, and put the energy into it, you can sell it. That's where you can find and purchase it. You can be my plug. Like, but for the most part, your microbiome is fragile, and it's like titanium all at the same time. So because they have their own, kind of protections and things like that, that's also why when they're off balance, it affects you directly and almost quite immediately. So they end up changing the things that they secrete, which can cause other problems, ingestion, all that stuff. Like a lot of chronic diseases and illnesses and things like that have been linked to a non-diverse or diminished microbiome. So that's why probiotics have been getting like they kind of become the star of the show in a lot of situations, because they're extremely important. Like, they're vital to our survival. Like I said, you can't even absorb certain nutrients without your bacteria, without this bacteria, your microbiome. And they also protect us from a lot of stuff too. So your immune system relies very heavily on your microbiome. So if you have autoimmune diseases and things like that, they tend some people tend to be treated with a probiotic, or to help strengthen your immune system and not make it want to attack you. So because your microbiome is quite apt at identifying stuff that doesn't belong, like I said, they're very territorial. So making sure that they're healthy and spry and ready for the job is definitely key to a lot of stuff, especially when you're detoxing heavy metals. So things like cadmium, silver, all that stuff, like trace amounts are found in like some of everything: the air, the soil, your water. It just depends on the area that you live in. Like, there's a lot of industrial complexes and facilities and things that have been shut down, so you may not be aware of the possibility of you being exposed to this stuff. But if they were ever active in that area is absolutely still contaminated with that stuff, because unfortunately during the Industrial Revolution, nobody had the foresight, knew about the possible long-term effects of those things being dumped into waterways or buried in the soil. And a lot of those companies are non-existent at the time when they created the regulations to clean that stuff up, to not dump it. So there's plenty of stuff that's still buried somewhere, plenty of stuff that's still at the bottom of the ocean, like in the ground, like all kinds of stuff. So there's so many places of, points of contamination. You can't really protect yourself from all of them. All you can do is just make sure your body is efficient at removing it from your system. And by doing that, you can ingest these chelating factors that are found in things that are high in antioxidants, your fresh fruits and vegetables, your green teas. Like I said, these they're called supplements, but really, I mean, seaweed and stuff, it's not a supplement, but I guess because they process it into a powder, they consider it a supplement, but they have their own nutritional value as well. Like spirulina, sea moss, all that stuff, they have nutritional value. So if your diet is lacking or deficient in certain things, you can definitely supplement it with these highly nutritious, quote unquote, superfoods, and drink more water. Get you a filter. We have filters on our faucets and things, so it's not like, oh, the water pitcher is empty. Like, just turn the spout on, flick the little filter, and you can get it directly from the sink in a glass of ice. And it's a lot more environmentally friendly than buying these dollar bottles of water from the dollar store that somebody probably filled up out of their backyard hose. Like, you don't know where that water came from. I don't even like bottled water. It tastes funny to me. So when you I don't know, when you cut out a lot of like processed stuff and strange foods, like, you can taste food, you can taste everything. So I can taste the difference in the water. I can, like, the water in Chicago tastes completely different from the water here in Ohio. And I've drank both straight out the faucet, no filter, no none of that, and I can taste the difference. Like, I can taste the difference between every bottle of water that I've drank. Like, the brand, I can't tell you the brand because I don't follow like water brands like that, but I know, like, I'll know it's a different brand of water if I'm drinking it, just based on the flavor. Yes, water has flavor because it has electrons, minerals, and all kinds of unseen stuff dissolved in it, and your taste buds are gonna react to that differently. And the more in tune you are with your body, the cleaner you have your system, the easier changes and things are identified. So, like, when I cut out fast food, it was like the one time I like ate something, I was like, oh no, this ain't it. Like, my body was immediately like, girl, you was doing good. Where the salad? What is this? What that? Like, I had some it was like some KFC, like, chicken nuggets or something, the little popcorn poppers, chicken poppers or something like that. And I digested all of the chicken. No food came. It was crazy. Like, my body like knew. It was like, no, we'll take the chicken, but what is this? And like, I couldn't handle it, and I threw up, and it was all grease. All grease. There was no solid nothing, and it was just all grease and water. I had drank some water because I wasn't feeling well, so I was drinking a lot of water. And that's exactly what my body expelled, all of that water, because oil floats on water. So it just like, oh, thanks, now you can help us get this out of here. And it was all grease. And that, like, when I saw that, blew my mind. I was like, yeah, I'm done with fast food now. Like, that's it. Even my body knows it's trash. Like, it didn't even accept the oil that they fried the chicken in. So it's not even like they don't even use good oil. Like, they can't use lard anymore because I believe it's FDA that regulates them. But whoever regulates the fast food industry said y'all can't use lard anymore. And that's why everybody was like, oh, this tastes so good. Because apparently when you fry stuff in pig fat, it tastes delicious. So, but it also clogs your arteries. And there was people, that's where the triple bypass and stuff came from. People eating that lard. So they no longer fry it in that, but they fry it in hydrogenated vegetable oils, which might be worse, because at least pig fat is still natural. Like, it's processed biologically, and it's created biologically. So we do have some type of method for breaking that stuff down, and a use for it. It's just when you overdo it, when you eat too much of it, that's how you get those plaques. If you're not eating enough stuff that actually reduces plaques and reduces that type of cholesterol in your blood. And like, so that's the thing, when you overdo the terrible stuff, you end up with a terrible system and a terrible body. So you have to offset that with the good stuff. So I'm not saying like, you got to eat 100% clean all the time, especially if you weren't raised like that. It's going to be very difficult, especially when you first start off. But definitely start, adding in more vegetables. If you're going to go to KFC and get you that bucket of chicken, don't eat the whole bucket in one sitting. Like, eat you 2 pieces. That's it. And that might be still overdoing it, but 2 pieces, and then get you some vegetables. Get a whole bunch of vegetables. All right, and then go from there. So, did you have any questions, Jate? Any comments? I know who I was here, but that's the end of my rant. Oh yeah. Oh, so did I say that? Yeah. So vitamin. Oh yeah, this was a nice little tidbit. So vitamin B1 B6, and vitamin C deficiencies are associated with poor tolerance of heavy metals and easier toxicity. So, being vitamin deficient actually makes you more susceptible to heavy metal toxicity and exhibiting symptoms of heavy metal poisoning. So, a lot of times it's usually associated with fatigue, like kind of off fogginess of thought, like stuff like that, and even like kidney damage, because a lot of the heavy metals kind of float in the fluids, and our kidneys filter that stuff, and even liver damage, because our liver filters a lot of toxins out of our body. And so if you are already kind of in danger of like fatty liver disease, so that is why one of the things to avoid is alcohol, because alcohol affects your detox system, your liver, which is your main detox system for a lot of things in your body. Like your liver is like, okay, it's the one. So if you are having liver issues, a lot of other, like, I guess, subsequent diseases tend to crop up, not necessarily because you are doing something to, I guess, promote that disease, but it's mostly just because your liver isn't detoxing your body as effectively. She can't get in the pens. This girl is a trip. So that's why I say, instead of pouring your money into all, like, these detox fads and things like that, take care of your kidneys and your liver. Drink plenty of water. Eat your antioxidants. Antioxidants are heavily abundant in berries, so that's why I say wild blueberries, mostly because like the farm versions of food tend to not be as not necessarily nutritious. The word has escaped me, but when you domesticate stuff, a lot of the stuff that made it good in the first place can easily be domesticated out of it, because sometimes the wild conditions, the environmental conditions, is why it even had those properties in the first place. So and another thing that I found was interesting to avoid: brown rice, mostly because it tends to contain arsenic. Arsenic is a heavy metal, and it's very toxic. Okay, so you're eating your rice varieties. There's plenty of other rices to eat. They have the wild rice and things like that. So avoiding brown rice is easy. Most people don't eat brown rice anyway. They prefer the white rice, but white rice is terrible for you because it can give you diabetes. Boom. So yeah. Make sure you don't overdo it with your processed grains, and white rice is very processed. That's why it's white. Um, and larger, longer living fish. So the longer the fish lives, the bigger it is. So big fish tend to eat smaller fish. So there's this thing called biological magnification. So the little fish eat directly from whatever they eat, the little seaweed or little plankton, this little stuff in the water or whatever. And then the big fish comes along and eats the small fish. But the bigger the fish, then the more access to different sizes of fish under its size it can eat. And so larger fish eat larger fish. So you got little tiny fish, and then it eats a bigger fish and a bigger fish and a bigger fish and a bigger fish, and then this big fish comes up and eats that fish. And so now that's where the biological magnification comes into play. So the concentration of mercury in small fish is very small because the fish is small. But as it gets eaten by larger and larger fish, that concentration increases. And not to mention that fish is getting its own exposure to mercury just from being in the water. So that's why it's better to avoid the larger fish, not necessarily because, I don't know, whatever, but it's mostly just because of biological magnification. It's probably eating a whole bunch of other contaminated fish. And the longer it lives, the more of that contaminated fish it can eat. So I actually had a list of like the fish that is usually lower in mercury, and it's salmon, because salmon is a freshwater fish. That sounds right. It's freshwater. Yeah. So it's not a saltwater fish. It's a freshwater fish. So that's one of the things. And salmon, not tuna, sardines and anchovies. Yes, and they're smaller fish. Duh. See, there you go. So, and sardines are super easy to eat because they're small and their bones tend to be edible as well. So you get like a whole lot of nutrition out of the fish. So yeah, and they have plenty of. I went to the store. They had a whole row of sardines, different flavors, soaked in different stuff. You can get it in water, you can get it in oil, you can get it with garlic and some type of herb, you can get it with lemon and butter. You can like that, yeah, and hot. They got it in hot sauce too. Yes, so they make sure they have a nice little selection, and I'm so glad that the food manufacturers are keeping up with this, with this body of knowledge and really trying to show that they care about the people that they're selling the food to. So they are having more of the healthier things that people are looking for available, and I mean that's good capitalism. Okay, so as demand for healthier foods rise, you're going to see a larger variety of things that are better for you. So I love this worldwide movement of getting yourself together because it's better for everybody. And what's good for the goose is good for the gander, huh? Oh, maybe not. I don't know. Sometimes people talk mess about that little saying. But definitely pay attention to yourself and how these things affect you. Some people like myself, I don't overdo it with the green teas because like I said, I'm anemic. So if I drink too much green tea, it actually binds to the iron and it makes my anemia worse. So I have to like gauge that and then, make sure I'm not overdoing that situation. But if I'm in a detox, kind of system, time frame, then I will add green tea to my cycle of drinks that I'm drinking to help that process along. This was fun. That's all I have for y'all today. And what are we on? Group 4 elements. So we're getting closer to the stuff that I love to talk about. So what's in that group? No, nitrogen that's the 5th group. Carbon. See, brain fart, okay? I might be low on boron. So group 4 elements or group 14, like I said, they have, different situations. But carbon is the top of that group. And then all of the ones below that have 4 valence electrons. And the reason why this group is so, I would say, stable without being a noble gas is because it has these 4 electrons so it's like on the fence. So it doesn't necessarily want to lose electrons. It wants to gain electrons, maybe. So depending on the situation, it will either lose or gain electrons. And also the trend going down the group is a lot more I would say a lot more prominent as the size of the element increases, because like I said, as these valence electrons move further and further from the nucleus, which contains all of the protons, which is all the positive charge, these electrons are less likely to be held onto. So the larger elements in the carbon group are more likely to lose electrons than carbon, and carbon is more likely to accept electrons than the larger ones because its proton, its positively charged nucleus, is trying to reach out and grab electrons as opposed to lose them. So that's going to be an interesting one. And then we're going to get into one of my favorite subjects, organic chemistry, because like I said, that is literally what organic chemistry is about. Anything that is carbon based. So we are carbon based. So organic chemistry deals very heavily with things that involve us. So that's what really got me on that track to biochemistry and being more involved in the study of the human body and systems and things like that. So getting ready for RockTrue Beats coming up in 45 minutes. Okay, make sure you tune in because you saw Marley King pop up, so I probably sparked a little something in him, and he tends to take it and run with it and applies it in a very unique and interesting way, especially when it comes to music and sound and vibration and how we, resonate with things like that. So I always love the conversation, and make sure you tune in so you can get in on the conversation and definitely hear some nice vibratory music, because they definitely been coming with some hits. I'm gonna have to get them to shoot me like a playlist or something. Like, y'all should come out with a RockTrue Beats playlist, so y'all can just be like, hey, woo, just send the playlist. Like, just go ahead, there you go. And then you can find, whatever artist you vibe with the most, you can find them and, get their contacts and stuff like that, and, find different ways to support them. So I am hungry now, and I'm pretty sure my daughter is too. So we're gonna eat and get ready to tune in to RockTrue Beats, and make sure y'all do too. And tune in next week to talk about some organic chemistry and more fun stuff. And make sure you bring your questions and your curious mind, and we're gonna dive deep. So make sure you rock truth or nothing at all.